title in the program, I think. It's basically stating what I'm going to talk about. Shall I move to this microphone or keep it this way?
No, you can move to that. Whatever works for you.
Well, actually, no, I don't do it. I'm too wobbly anyway. So, test. Yeah, working. So it tells you what I want to talk about, but it doesn't tell you what I want to achieve. I want to achieve three things. I want to inform you about the whole CCS situation in Switzerland, which is of a slightly different scale than we've been hearing before. I want to, introduce you to our opportunity that we're currently having. And I want to pose a couple of provoking questions, because obviously I didn't come here for your questions, but I come here for my answers. So hopefully I can achieve that. Before I move on, I would like to make you aware of my many colleagues helping me out here, some of which have been involved in the project we've been hearing about, the Madritsch lab, for example, but also the Demo Upcama project shipping CO2 to Iceland. These people are helping us here a great lot. Okay, I start with one of my biggest weaknesses, numbers, because I'm a geologist, indeed. Yeah, but I thought these numbers are important for you, so just that you know what we're dealing here with in Switzerland. As I've already joked this morning with Caroline, we are on the top left of her plot on emissions versus budget. So we are richer, apparently, than the Americans, and we emit less than the Somalis, which is impressive for me to see, because I'm only in this business for a year or so. But from a geologist's point of view, the challenge that we are facing are still quite large. We would like to store about 3 million tons of CO2 in Switzerland by 2050. And as you will see, the geology makes already this little bit, by comparison, already quite challenging. That is to say that we are really at the bottom of this very complex graph that is presented by the Storage Resource Management System guidelines. And I would say that's totally true. We are somewhere in the undiscovered storage resource box, just above the basin play status, where it says, has the evaluation specified a geological sequence by name? Yes, that's true, but there's a long way to go. Not talking about business models, not talking about industries yet, but also not of any regulations, really. That's good. That's the geological picture I have to present. Of course, it shows you exactly these geological units by name. You don't have to go into detail. All you have to see on this graph is basically there's a lot of orange. That's potential cap rocks, and that's also where my history comes from, nuclear waste disposal exploration. So we have pretty tight rocks in Switzerland. And the bluish colors, they are rather subordinate. That would be the reservoirs. So the big question is, do we have reservoirs really to store this CO2? And I want to talk about this probably most promising reservoir, the Upper Muschelkalk, in a second. This is a rock that has already received quite some attention in the past. It has been mapped out on the basis of a couple of boreholes that are the blue dots here, so drill core observations. And the findings are a little bit pessimistic, I would say, because it resulted in a perspective that you're seeing here, namely that the Swiss Marles Basin, which is this on the topographic map that is maybe a bit more familiar to you than this geological expression, the basin just north of the Alps, features the Muschelkalk all over the place, but the rock matrix porosity of the Muschelkalk is expected to be really, really low and is sufficient for CO2 storage from a certain depth onwards, where the matrix porosity breaks down. As a structural geologist, I would say maybe this picture is a bit too pessimistic, because it doesn't take fracturing and tectonics into account. And as you can see from the yellow lines, we got a couple of nice faults in the Mollis Basin as well, and fractures. And so maybe when considering these fracture systems, this picture has to be slightly revised. What comes in new to us now is this yellow dot here. That's the borehole Trilicon 1, which was drilled in the context of nuclear waste exploration. Practically, I placed it a couple of years back, and I'm kind of in a chameleon role now to see whether we can use it for something else than just looking at the cap rocks. And in fact, yes, the borehole drilled the Muschelkalk at a depth of 1,100 meters. And we'll look into the nice features of this rock in a few more slides later. First, I want to talk to you about where is Trilicon, because I'm pretty sure you don't know. Trilicon is about 30 kilometers north of Zurich, so close to the border to Germany, and it's this so-called area in the north-central part of Switzerland that is also sometimes referred to as Nagra land, because Nagra, the company I used to work for 14 years, has explored this area to a great detail with a huge drilling campaign just being done. And it's probably one of the best explored areas in Central Europe, in fact. So we know quite a lot about this area, and the borehole that is being offered to us is also of quite some value, as you will see, because there is a lot around this borehole than just a mere hole. The hole, as said, is 1,300 meters deep in total. It has drilled the storage complex consisting of the Muschelkalk and its immediately adjacent caprock. It is very well documented. We have a 3D seismic around it. There has been a lot of geomechanical and hydrogeological testing on the course, but also in situ. Models of regional and local scale have already been established. And one very important point, as I found, is that the local population is also kind of desensitized already, because until very recently, these folks were confronted with the question whether they will receive a nuclear waste repository. So the perspective of having a little bit of CO2 injection is actually quite okayish. Yeah? And that's why I posed the question to my colleagues whether this borehole should not be taken over by Nagra for doing exactly what Carrie has just outlined very nicely. A pilot CO2 injection test for Switzerland, which would certainly be the first of its kind for our country. Obviously, there are many questions, and I don't want to go into all of them today, especially since Carrie has already nicely addressed them. All I want to talk about a little bit here is goals, borehole usability, and technical feasibility, right? So let's start with the obvious. Is the borehole that has been drilled for exploration purposes of the Alpine clay, to mention that caprock once, actually feasible to make a CO2 injection? We engaged with, from my homeland, an Austrian drilling company to assess that from a very out-of-the-box perspective. And luckily, they found that the borehole was executed quite well. The cement is of perfect standard, the casing is good, and as such, the borehole should withstand the expected loads of about 15 to 18 megapascal. A CO2 injection at the depth of 1,100 meters could, at the max, be exposed to, taking into account the minimum recent stress data that we have looked into. That being said, it's not yet ready yet. There's some more work to be done on the borehole. A special tubing needs to be installed. We need a packer, we need perforation and so forth. And this would amount to some 1 million francs, which is not nothing, but considering that the borehole's worth, including the testing, is around 20 million, it's still okayish if you're on the left upper part of the box. Let's look at the geology. The geology is, of course, as I said, challenging. We carried out a lot of fast-forward work now on the Muschelkalk together with ETH and the University of Bern. And if you look at this plot here that was provided by the University of Bern, you can see easily that Trilicon, that is that true red dot, doesn't plot too well when it comes to your typical storage properties. The permeability of the rock, the matrix permeability, is very low, 10 to the minus 13. But you can also see there's another red dot, which is a borehole just about 2 kilometers away, which actually plots quite nicely in that box. And we're going to look at it, or what the difference of these between these boreholes might be. I also would like to mention, as the question came up earlier, that we are doing a lot of modeling, of course, with all that data that's all around already, around this borehole, and we're going to also take a look at that. But first, let's look what the geologists like to do the most. Let's look at the rocks. It's very well documented. Here you can see the cores that were retrieved from the borehole, and you can also see why that Muschelkalk has always raised attention to CO2 storage people. That is, of course, because there is quite some obvious macroscopic porosity in the rock that stems from anhydrite dissolution. Yet still, obviously, from the permeability analysis that we made, these pores are not very effective, right? So what makes these rocks more permeable? It's fractures, right? So in this other borehole, the Martan 1 borehole, we actually drilled into quite a lot of open fractures that sucked a lot of mud and made this borehole even more expensive than the other one. So you can get something into this rock if it's fractured. And as a field geologist, that didn't come as a surprise to me, because if you go out to the field and look at these rocks, they are actually very much fractured. So the question is if a vertical injection borehole is the right thing to go for in the future, or we maybe need a different measure to get the CO2 into the rock. Talking about the benefits of fractures, we also have to talk about faults, of course. This is the 3D seismic image around Trilicon, and it also shows you that Switzerland is a small country with a lot of faults, so spaces are limited. And this is what we have to deal with here. We're actually quite close to a couple of seismic scale faults. That means some faults with some 20 meters of vertical offset. And at great depth, some of these faults also show seismicity, like in 6 kilometers depth or so. So the question is, can we really afford to make an injection here, and how big can it possibly be? Given the low permeability of the rock, we're actually not looking at a big operation. And this is a preliminary model by Antonio Rinaldi from ETH that I kind of like, because it shows a little bit of my background when you see the timeline of the model, because the timeline is long and there's nothing happening for a long time. And if we look at it on a nuclear waste scale, that is probably some 20,000 years here. You can't see it, I guess. Yeah, it's 10,000 years. Of course, the CO2 is going to migrate somewhere else. But the obvious, immediate landowner perspective is that for the first 20 years, not much is going to happen if our models are correct. And I'm very sensitive about that, of course. But it makes for a good communication basis to say, look, we're not doing that much of a deal here. Nevertheless, saying that, detecting, monitoring the CO2 of these few volumes or little volumes will be one of the major challenges when we're talking about the goals of such an endeavor. Current evaluation status and considerations. So far we have not found any technical showstoppers. The main uncertainties regard the effective injectivity and the monitoring possibilities. And as such, towards the takeover decision that is due end of the year, we are facing multiple scenarios. No go. We leave it as a nice desktop study and another presentation maybe next year. Zero scenario, that would be really bad. We take over the borehole, we inherit the costs for abandoning the hole, but for some reason, the landowner changes his mind and we cannot inject anything. Bad. Yeah? And we need, of course, someone to help us with this kind of risk value. Scenario one is very modest and maybe not so good for the perspectives of CCS. In Switzerland, we can only able to inject very little. Scenario two is actually what we consider the one we should aim for. We are able to inject maybe about 10,000 tons over 2 years, are able to monitor it somehow with a method that you're going to tell me about, and we're good. And scenario three, of course, would be, for example, if we really make it into this fracture system and inject much more and have to revise our maps, right? So the question maybe is, from a very left corner of the box perspective, is it worthwhile to do that? Yeah? But of course, I'm an idealist. And I would also ask the question, can we afford to not take a chance and try it out? And I'm interested to hear your thoughts about that. After all, it's really a question of goals and significance. The premises of the project is clear. It's a low-cost opportunity to pilot test the CO2 injectivity of a nationally important CO2 storage complex. And I would also like to say that while we face some risks regarding the scientific goal achievement, of course, there's a great lot to learn, as Kerry has told us, from such a pilot in terms of skills and competency development, communication. I like to say I have already been in the living room of the landowner, and he's a big dog. So we have to be careful what we're doing here. And of course, research and innovation, last but not least, and that's why we're working primarily with academic institutions on this at the moment. I come to my conclusions. Already now, we sparked a lot of activity in my first year of CCS activity with this whole feasibility study. And so far, as said, we have strong community support. From a commercial and scientific point of view, CITRU is an opportunity offering limited possibilities, that's for sure, and bears some risks regarding scientific goal achievement. Obviously, for that reason, the planning of next exploration steps, more 3D seismics, more validation should happen in parallel, so it's not going to be the holy grail. We would need to embed CITRU in a broader community effort in this regard. And last but not least, we want to decide on this by the end of the year. So if I raised your appetite to learn more about this decision, I may invite you to our own little event that's coming up in around my birthday, in fact, January 24th. And maybe we visit you or see each other again at Monterrey in the Swiss Jura Mountains.